Hello everyone, welcome to Neso Academy. We have already covered data types, data objects and operators. So we know how to store data and we also know how to perform operations on data. But how do we actually describe the behavior of a circuit in VHDL? For example, how do we describe a logical flow? Or how do we control an execution? Or how do signals interact with each other? Because finally, VHDL is all about describing hardware behavior. And for that, we use VHDL statements. So, in this lecture, we will understand what are VHDL statements. Let's start the lecture. Now, VHDL statements are used to describe the behavior and operation of digital circuits. Meaning, VHDL statements are the instructions that we write to explain the behavior and operation of digital circuits, or how digital circuits should work. Overall, VHDL statements are the instructions that we write in VHDL code. Second point, VHDL statements define how signals, variables, and hardware components interact. That is, VHDL statements define how signals interact, how variables change, and how hardware components behave. And there are mainly two types of statements in VHDL: concurrent statements and sequential statements. And in this lecture, we will understand both, starting with concurrent statements. Concurrent statements execute at the same time. That is, concurrent statements execute in parallel, like a real hardware, where all components work simultaneously. Example, these three statements in VHDL will execute in parallel. Let's take another example to make it more clear. Here I am declaring three logical statements. First statement containing AND operation, second statement containing OR operation, and third statement containing NOT operation. Now all these three statements will execute simultaneously. Now what will happen if I rearrange them? Example, if I write the statement containing OR operation at first place, then second statement containing NOT operation, and third statement containing AND operation, what will be the output? The output behavior remains same because concurrent statements execute in parallel. Each and every statement execute at the same time. So, I hope you understand what are concurrent statements. Let's see the second type, which is sequential statements. Sequential statements execute one after another in order, and each statement waits for previous statement. Sequential statements execute one after another in series, and each statement waits for previous statement. Example, this statement 3 will execute only after statement 2 is already executed, and in the same way, statement 2 will be executed only after statement 1 is executed. Now, let's take an example to make it more clear. Sequential statements are mainly written inside a process block. Now, we all know what is a process block. Process block is mainly written inside the VHDL architecture, which contains sequential statements. So, inside process block, we can declare sequential statements. Process A, B. Now, inside the parenthesis, A and B are the sensitivity list, meaning if A or B changes, then only the code within the process block will run sequentially, one line after another. Example, the first statement, storing B inside the signal A, will execute, then only the second statement, storing A inside the signal C, will execute. So, statements execute in series. Now, let's take another example to make it more clear. Consider this if statement. Here, first these two signals are compared, then store A in signal Y. If condition is not satisfied, then move to the next statement, which is storing signal B inside signal Y. So, overall, sequential statements execute in series. So, I hope you understand what are sequential statements, which means we are done with this topic of VHDL statements. So, VHDL statements help us describe how digital hardware behaves, and understanding sequential and concurrent execution is one of the most important concepts in VHDL. So, I hope you understand this lecture very well, which means we are done with this lecture. I will see you in the next one. Thank you.